Hello, class. Welcome back. Thanks for tuning in. Um, we are going to jump right in here. I hope that you're safe and healthy. We're going to jump into our lesson. This is week 7, part 1 today. And so if you're sticking around, thanks for that. If you're going to try out the Google form, you can go ahead and try that out after the video, or you can try it now. I mean, it doesn't hurt. But again, let's go through the video and kind of see what we're doing here. So the basic rules that we're doing here is we are going through scientific notation still. This stuff we did last week, but now we're going to be using it. So we're going to be like adding numbers and subtracting numbers and multiplying and dividing. Something that I kind of gave a hint on in the last video, where we went through some of the Google form problems from last week. I think that video was Thursday or something like that. But today we're doing sum and difference. That means adding and subtracting, and then products or multiplying, and quotients or division. But we're doing it for scientific notation. So this is really like the purpose of why we have scientific notation, is making really big numbers smaller so you can do them easier. Now, before we start, it comes down to just knowing the concepts of Algebra 1. Now, what I mean by that, I'm going to explain, and this is the concept that I'm going to be using throughout the day. So, here's the thing. For those who are familiar, just kind of remember the rules. Let's say that I had a 2x and a 3x. Now I was going to add these two together. Now they have the same variable. So they're what we call like terms. And you can add them. You just add what we call the leading coefficient, the leading number out front, and you get 5x's. Right? Now notice, the x's didn't change. The labels stayed the same. It was just a label. It's like if you had 1 apple and 2 apples, right? You'd have a total of 3 apples. Well, the idea is that this is the same concept. I know this is weird, but this is what we're going to be using. This concept of like adding like terms or subtracting like terms, same thing. You could subtract the 2. So, maybe I put a minus sign in between them. So I'm going to subtract 2 minus 3. Well, it's a negative 1x. You can do that. That's totally fine. Now you're thinking, okay, well, we did scientific notation. How does it deal with x's? The x will be the thing that changes. That's going to be your power of 10, let's say. And so if we can make those powers of 10 the same, it's like they have like terms, like the x's here, and then we can add them, or subtract them, or multiply them, because you can actually multiply anything. Now adding, you have to have the same variable, but on multiplying, let's say this is the items we're multiplying, we can do that. Now these don't even have the same variable, but you can still do it. And how you actually multiply these is you multiply the leading number out front, so the 2 and the 3. You'd multiply those together. The variables sit in the back, like that. I know that seems weird, but that's the correct way to multiply variables together, and like terms, not even like terms. But what we're going to get is we're going to get a 6 out front. That's 2 times 3. And then for the x's, well, there's just a total of 3 x's there, because they just get thrown in the back. Well, there's 2 there and 1 there, so that's a total of 3 x's. That concept, what you just witnessed there, is exactly what we're going to do for powers of 10. So if we multiply them, we're just going to add the powers of 10, because they're just variables in the back, and you just combine them. Now that's different than adding and subtracting. Because adding and subtracting, you're just using them as a label. But when you multiply, you actually have to change the labeling. It's like going from, if you multiply feet times feet, you get feet squared, or square feet. Right? Well, that's what we're doing here. We're making a new variable completely. Division, same exact idea. You just divide them, and division means you subtract. Like in this case, I added the 2 variables. When you multiply, on division, you subtract the 2 variables, top minus bottom. That concept is what I'm going to use today for this little scientific notation idea. So let's jump right in. Let's take a look at the first problem here. Okay, so we're subtracting on this first one. We're subtracting 5.6 times 10 to the 4th minus 3.2 times 10 to the 4th. I know it's going to seem really weird, but it's like we're doing this. 5.6 x's minus 3.2 x's. That's kind of like what we're doing. It's not the exact concept, but we're just subtracting the leading numbers. We're subtracting 5.6 and 3.2. The variable isn't going to change. We're just going to throw the variable in the back. The x's will stay there. It's like when I did the apples or candy bars or whatever you do, or whatever your label is. You just add or subtract the front number. So let's do it for this problem. So let me go up here. So if we're subtracting these, they have the same variable in the back. That's going to be my times 10 to the 4th. So that's going to be my part in the back when I subtract. But the part in the front, I'm actually taking the 5.6 and subtracting the 3.2. That's what I'm actually subtracting. These are the leading coefficients, the leading numbers out front. You just subtract them. So 5.6 minus 3.2, if you just subtract straight down, I'm going to get 2.4. And that, no joke, is your answer. Now, to prove the point, because I know some of you will be like, there's no way that just worked out that way. Let me pop up a calculator, and we're going to take a look at it. And I'll keep writing on my iPad so you can see my calculator and how we're doing it. I want to make these real numbers so you can see that it actually does end up being this. So calculator here so you can see it. All right, so now, writing these as real numbers, 5.6 times 10 to the fourth. Well, that means I moved the decimal 4 spots, like this. So it's actually 56,000. Now, how I know that? It's a positive power, so the decimal has to go, to the right. Same with the 3.2. I'm going to move that decimal 4 spots, so it's going to be this. Moving that decimal 4 spots over, so it's in the very back. And then when I subtract these, I'm going to get the answer. I don't even need a calculator, but I'm going to still type it in there just so you can see it. Let me type it in the calculator here. So I have 56,000, and we're going to subtract the 32,000, and we're going to get 24,000. Now I know that seems a little weird to write it like that, but that's the answer. That is this thing right here. 2.4 times 10 to the fourth. 2.4 times 10 to the fourth, that means you have 2.4 times 10 4 times. Right? Maybe that's a different way to look at that. It just moves the decimal. That's all times 10 is. So if I just type in 2.4 and take it times 10, times 10, times 10, times 10, 4 times, you get 24,000. It's the same answer. It's so weird how this works. And now you're probably thinking, okay, Ward, I could have just typed it in the calculator. Yeah, but let's say technology fails you. Or, your calculator runs out of batteries, or your cell phone dies. You can do it by hand. It's simple. You watched me do it in a few seconds. 5.6 minus 3.2. And then just put the times 10 in the back. Now, if we go to the next problem here, we take a look at it. Alright, now I got a little small. I'm going to apologize for that. Got a little small. There we go. Okay. We're going to multiply. This is just like what I did earlier with the powers of 10. We're gonna take a look at that. Let me transition back to the. So if we're gonna multiply these two numbers together, the times 10s to the fourths go in the back, and they're just like labels, right? So I'm just gonna take that times 10 to the 4, times 10 to the fourth. Those go in the back. It's because when you multiply, the labels will change. In the front, I'm just gonna take 1.2 times 3.4. Those are the leading numbers. I'm gonna just multiply those. Now again, if you want to take a look at a calculator, you could do it by hand. I know that's something that a lot of people don't like to do. It's literally just 12 times 34. And then you just throw in the decimals in there. So 12 times 34. So I'm going to do this old school column method. If you don't like that, you can do the lattice or whatever. So how you do this by column, you take the 4 times both numbers on the top. So 4 times 2 is 8. 4 times 1 is 4. Now the 4 is done. So now I'm going to move on to the 3. Now the 3 is kind of one space over. So I'm going to put a guard dog here, or a filler. Because the 3 is technically over one spot, so I have to put a filler. 3 times the 2 on the top, that's 6. 3 times the 1 is 3. And then you add straight down. So that's an 8, that's a 0, and a 1. So this is 408. Now again, just do that. Typing in my numbers here. 1.2 times 3.4. Boom, 408. Now, the decimal is in a different spot, and you're like, Ward, you said 408, that's 4.8. Because I threw the decimals when I did the calculator. So if I go back to my work here, and you kind of see what I did here. All right. This problem had 1 decimal. This problem had 1 decimal. So total there's 2 decimal places. So I just moved the decimal over 2. So right now it's here, because I said 408. I moved over 2 spots. It's 4.08. Now that's doing it by column method. I know that seems a little silly, but doing it by hand. So technically, this is my answer currently. Times 10 to the 4, times 10 to the 4th. Now, that's a total of 8 tens. I'm just going to put them all in the back. There's 4 and 4, that makes a total of 8, not 16. Because technically what that is, it's times 10, times 10, times 10, times 10, right? There's 4 tens and 4 tens, so that's a total of 8 tens across, if you think about it that way. So, there's your answer. That's the exact answer for this problem when you multiply. Again, scientific notation makes multiplying easier. It's to make numbers smaller so you can kind of do them in your head, or write them on paper and make it easier for yourself. Let's go to the next one. So we got a few more problems here. So I kind of picked just kind of a range of different ones, so adding, subtracting, multiplying, dividing. So we're adding on this one. Now notice that the times 10s are different. So when you add, they have to have the same label. So I'm going to make this one a little bit different. So I'm going to make this a times 10 to the 5th. So if I move that, here's what I have. I have 0.57 times 10 to the 5th. Because if I move that decimal back 5 spots, it'll be the same number as the one up above. Just to prove my point, because I can change, if I move the decimal, I can change the power. So if I move this decimal back 5 spots, it's 57,000, like that. 1, 2, 3, 4, 5, yeah. The decimal would be in the back, and on the original number it was 5.7, and I moved it 4 spots, 1, 2, 3, 4, and yeah, it's still 57,000. So it's still the same number, I just wrote it differently. Now, you're probably thinking, okay, why did I write times 10 to the 5th? Because the other one has times 10 to the 5th. So when you add and subtract, you have to have the same label. Multiplying didn't matter, but adding you do. So really what I'm doing is I'm adding 4.87 plus 0.57. I'm just adding these, and I know my answer in the back will just have a times 10 to the 5th on it. Because when you add and subtract, the labels don't change. Apples stay apples, right? It doesn't suddenly change the label when you add them together. So if I add, that's 14, carry 1. 9 plus 5, what is that? 14 again, plus 1. And 1 plus 4 is 5, and the decimal comes straight down. So this is 5.44 times 10 to the 5th. And again, if you type these numbers in the calculator, you should get the exact same answer. Okay, moving on to the next one. Here. Ooh, let's go. Alright. Okay, now we're dividing. Now this is one we haven't done yet. Dividing, I'm going to put one number on the top, one number on the bottom, right? So it's like this. 4.3 times 10 to the 9th. 2 times 10 to the 4th, and these are being divided like a fraction bar. Now, when you divide, the powers of 10, instead of adding like with multiplying, we just add the powers of 10, we're going to subtract these. Top minus bottom, so I'm going to have a times 10 to the 5th, right? 9 minus 4. So there's 5 tens left over. Now for the other number, the 4.3, I'm actually going to divide it by 2. So 4.3, divide that by 2, and whatever this answer is, that's the part that goes in front of the 10 to the 5th. Alright, so 2 goes into 4 twice, so that's a 4. Subtract, you get 0, bring down the 3. 2 goes into 3 once. Bring down the 1, I have another 0, because you can always put zeros in the back. Bring this straight down. 2 goes into 10 5 times. Alright, and so what we have, if this decimal goes straight up, it's 2.15, and again, you can type it in your calculator if you need to. But it's 2.15 times 10 to the 5th, and that would be the answer for this one. Alright, we got, what, a couple more here? We got about 3 more. Alright, so we're going to be multiplying here. So multiplying is pretty easy. You just add the powers of 10, you multiply the other two numbers together like we did earlier. So we're going to be taking 3.4 times 6.2. And for the times 10s, we're going to just add these two together. And I know that one has a negative power, but you add those together, and so we're going to have a times 10 to the 4th, because negative 2 and 6 add together to make 4 tens. Now, for the 3.4 and the 6.2, we're going to multiply those. Again, I can ignore the decimal place. It's basically taking 34 times 62, and I'll just move the decimals in the very end. Now I'm going to do this by column method again. You can do it by lattice, it doesn't matter. So again, if you don't remember how I did that, I start with this 2 in the corner, you multiply to everything at the top. So 2 times 4 is 8, 2 times the 3 is 6. So the 2 is done. I'm going to move on to the 6, so I have to put a guard dog because I'm moving one space over. 6 times 4 is 24, carry the 2. 6 times 3 is 18, plus the 2 is 20. And now add straight down. That's an 8, that's a 10, carry a 1, that's a 1 and a 2. And then the decimals, well, this problem had one decimal and a second one, so I'm going to move the decimal over 2 spots. Boom. So the answer is going to be 21.08 times 10 to the 4th. Moving on, we only got a couple more here. All right. So we're dividing again. So we're taking 8.4 times 10 to the 5th. We're going to divide by 1.4 times 10 to the negative 2. Okay, so now we are subtracting for the powers of 10 anyway. So it's not multiplying, we're dividing, so we take top minus bottom. So 5 minus a negative 2 actually ends up being 7. 5 minus a negative. So it's like this. 5 minus a negative 2. The negative signs cancel. So we're going to be adding those together. So we're going to get 10 to the 7th. Now, for the other numbers, 8.4 divided by 1.4. So 8.4 would be in the house. The number on the outside is 1.4. We have to move the decimal over because you can't divide by decimals. So I'm going to move that decimal over, so it's going to actually be a 14 on the other side. And I have to move the decimal on the inside one spot. That's just how it works when you move the decimals. So whatever you do on the outside, you have to do on the inside. So 1484. So I'm going to check how many times can that go in there. I think it can go in there exactly 6 times. 6 times 14, if I just think about this, 6 times 14 is a 4, carry a 2. 6 times 1 is 6, plus 2 is 8. So yeah, so it goes in there perfectly 6 times. So 8.4 divided by 1.4 is exactly 6 times 10 to the 7th. And that'd be the exact answer in the long run if I were to type these numbers in my calculator. You know, whatever the original numbers were, they are really big numbers, or really small numbers, in fact. All right, let's move on. We only got a couple problems left here. We're adding again, so we have to have the same powers of 10. So on that first one, I'm going to move this decimal over. So it's going to be 0.34 times 10 to the 4th, because it would just move the decimal back a few spots, so it would be the same number. And I'm going to add 5.6 times 10 to the 4th. So they can add these. So when we add, remember, the powers of 10s will not change, or when you subtract them, the powers of 10 will stay the same as long as they're the same power. And we're just going to add 0.34, and we're going to add it to 5.6. You have to line up decimals and you add, or subtract. Oh, that's a really bad plus sign. Adding straight down, that's a 4, that's a 9, that's a point, and that's a 5, so it's 5.94. And last problem, we're subtracting. Now the good news is, they have the same powers of 10, so we know my answer will be times 10 to the 7th. But now we're taking 4.108, and we're going to subtract 2.835. So doing this by hand, 8 minus 5 is 3. I can't do the 0 minus 3, so I'm going to borrow, making that a 0. This is now a 10. 10 minus 3 is 7. 0 minus 8, can't do it, so I'm going to make this a 3 here, make this now a 10, because you're borrowing 1. So 10 minus 8 is 2, and 3 minus 2 is 1, so it should be 1.273. Again, if you want to type these in calculators, it should be the same answers. Alright, I know I kind of went kind of quick there. That's kind of the idea what we're doing this week. We're using scientific notation to actually do mathematics. So if you're thinking about, like, well, how do we do this? Well, in real-life situations, you're going to have really big numbers. Well, there's some instances where your calculator can't do those numbers if you have a certain type of calculator in front of you. So you can make them smaller by changing all numbers, no matter what the number is, to scientific notation like we're doing here, and then perform the math. You know, do the adding, do the subtraction, multiplying, dividing, that type of thing. So it was just kind of a fun way to do it. I thought it was kind of interesting. Most people don't know how to do that. It's one of those topics that it is, you know, something you should learn, but just kind of one of those skills that most people just take for granted anymore. But again, thanks for all those who are doing these, you know, activities. I know a lot of you are always constantly checking and stuff, and I always really appreciate that. But remember, first priority is your health, safety. Take care of each other, and I hope to see you real soon.